All right, this problem number 2, let's take a look. And this is actually going to be an interesting integral where we're going to use work is the integral of force dx. And let's be clear that this work integral is going to be 2 cosine theta times this distance dx. Now what we're going to actually do is a special form of trig substitution where we have our tension T, we have a height, and so what we're going to basically try to do is figure out how this triangle works. So we have a height h here, we have a distance x here, and so what can we say? I can say that x over h equals the cotangent of theta, and I also know the cosine of theta. Well, we'll just leave that alone for now. So keeping this in mind, I can then isolate dx from my trig substitution and say that x equals h cotangent of theta, and dx is going to be negative cosecant squared of theta. So when I actually set up my integral, work is going to be integrated from x1 to x2, and the integral itself is going to be t cosine theta, and instead of dx, I'm going to write this as negative cosecant squared theta. Keeping this in mind, we integrate from x1 to x2. This is going to be t cosine, negative t cosine theta over sine squared theta. And we can do a u substitution. So u is sine squared theta, and du is going to be, u is going to be sine theta, and du is going to be cosine theta. So keeping this in mind, this is going to be negative x1 to x2 t du over u squared, which is going to give me t over u, and that's going to end up being t over the sine of theta, and we're going to do kind of a partial x1 to x2 here, and let's just sub in our trig stuff and solve. So sine of theta is going to be h over x squared plus h squared under a square root. We're integrating from x1 to x2. So this ends up being, the work is t over, actually, work is t times 1 over x2 squared plus h squared, all under square root, minus 1 over x1 squared plus h squared. And that should be our